we now discuss the solution of a problem from the section Sets, Relations and Functions. And the problem is to count the number of one-to-one functions. And this question has appeared in the Joint Entrance Examination Main held on 24th June 2022 in the first shift. The problem is the number of one-to-one functions f from the set consisting of 4 elements A, B, C, D to the set consisting of 10 elements 0, 1, 2, etc. up to 10, such that 2 times f of A minus f of B plus 3 times f of C plus f of D is equal to 0. So the problem is self-explanatory. There is no need to explain further. Now let's now discuss the solution of the problem in detail. So we want to find the number of one-to-one functions f from this 4-element set to this 10-element set. The domain is the set consisting of A, B, C, D, and the codomain is the set consisting of 0, 1, 2 up to 10, such that 2 times f of A minus f of B plus 3 times f of C plus f of D is equal to 0. And this will imply 3 times f of C plus 2 times f of A plus f of D is equal to f of B. This is the relation we will consider in all our discussions. Now, by the way, what is a one-to-one function? Say a function f is said to be a one-to-one function if the distinct elements of the domain D are mapped to the distinct elements in the codomain of the function f. So, we want to count the number of one-to-one functions in this situation and satisfying this relation. Now, suppose if I take f of c value is 4, f of c value will be 4, then 3 times of f of c will be 12. So that means it will exceed 10. So for these values, 4 less than or equal to f of c less than or equal to 10, 3 times f of c exceeds 10, and thereby f of A, f of A, f of D and f of B find no values. Therefore, f of c cannot take 4, 5, 10. Of course, f of c, f of c takes the other values. Thus, f of c can take the remaining values. The remaining values are 0, 1, 2, 3. That is 4. So, we will deal with 4 cases. We do it in the next slide. So, let's consider the first case. Case 1. Let f of c is equal to 0. And if I take f of A is equal to 5, then 3 times f of c 0 plus 2 times f of A will be 10. And if it is 5 less than or equal to f of A less than or equal to 10, then this value 3 times f of c plus 2 times f of A will exceed 10 and is greater than or equal to 10, and thereby f of D, f of B find no values. So f of A cannot take these values 5 to 10, 5, 6, 7, 10. Of course, f of A cannot take 0 also. So thus f of A can take values only, so other than 0, 5, 6 to 10, they are 1, 2, 3, 4 only. So we deal with 4 sub cases. Now let f of c is equal to 0, and first case f of A is equal to 1. Then f of D cannot be, so f of D cannot be 0 to 1. Why? Because if already f of c is 0, f of A is 1. If f of D takes any one of these values, then f ceases to be 1 to 1. So f cannot be 1 to 1. So it cannot take these values. And 3 plus f of c plus 2 times f of A plus f of D. What's the value? 2 plus f of D. 2 plus f of D. If f of D takes 9 and 10 values, so f of D cannot take the values 9 and 10 because this will exceed 10, and thereby f of B finds no value. So f of d can take how many values? 7 values. Why 7 values? It cannot take 0 and 1, and it cannot take 9 and 10. So 4 values have gone from the 11 element set that is codomain 0 to 10. So we are left with 7 elements. What are they? 0, 1, 0, you are not supposed to consider 0, 1, 9 and 10. The remaining values are 2, 3, 4, 5, 6, 7, 8 values. And for these values of f of b is equal to 2 plus f of d. Then f of b takes values respectively for 2 plus 2, 4, for 3, 2 plus 3, 5, like that. For 8, 2 plus 8, 10. So for these are the respective f of b values. For these f of d values, the respective values are this. So these are tabulated. This results in 7 one-to-one functions. 7 one-to-one functions. This is tabulated in this tabular form. F of c, f of a, and all these things are here. And f of c is 0, f of a is 1. This is the case, subcase what we have just discussed. 2 plus f of d, this value. And f of d cannot take 0 and 1 because they are already there, f of c, f of a values. And if you take 9 and 10 values, 2 plus f of d will exceed 10. Thereby you cannot find the value for f of b. Therefore, the possible values f of d cannot be 0, 1, 9, 10, and the possible values for f of d are these 7 values, and the respective values for f of b are this, and it results in 7 one-to-one functions. And in this case, I will show you explicitly what are those 7 functions. These are the 7 functions. And these functions are: c is mapped to 0, a is mapped to 1, d is mapped to 2, b is mapped to 4. Like that you have to read. c, a, d, b is mapped to 0, 1, 2, 4 respectively. Like that the 7 functions are here. And you can see these are one-to-one functions. No 2 elements are mapped to the same element here. And distinct elements in the domain have distinct elements in the codomain. Corresponding elements, corresponding images are here. Those images are also distinct, which you can see. So those are the 7 values in this subcase. So we consider likewise the other cases also. So now let's see. So this is our tabular form. This is our first case. And the second case, four subcases you have to consider: 0, 2, and thereby this will be 4 plus f of d, and f of d cannot take 0 and 2, and f of d can, if takes 7, it will exceed 11. 7, 8, 9, 10 it cannot take. So the remaining values are 1, 3, 4, 5, 6. These are 6 values. The corresponding values are these, that is 4 plus 0, 4 plus 1, 5, 4 plus 3, 7. These are FD values. 4 plus f of d values are written here, and these are 5 in number. And in the case 0 to 3, and this value is 6 plus FD, and FD cannot take 0 to 3, and FD cannot take 5, 6. If f of d takes 5, then it exceeds 10. So 5 to 10 it cannot take. The remaining values are 1 to 4, and the number of functions are 3. The corresponding values are here. So now that is f of a is 4, 0 to 4. These are the 4 subcases which you have to consider. And f of d, this is 8 plus f of d. F of d cannot take 0 to 4. F of d cannot take 8 plus 3, 3 to 10 it cannot take, and it can only take 1 to 2, 1 and 2, and the number of functions will be 2. So those are the 4 subcases, and in this case 1 you get 7 plus 5 plus 3 plus 2, that is 17 one-to-one functions, which will map f of c to 0, f of a to 1, and those in the case of the 7 which I have already written, what are those explicitly 7 functions. So like that you get 17 one-to-one functions. We go to the next scenario, that is the case 2. Let f of c is equal to 1. Then if f of a takes 4, then 3 times f of c plus 2 times f of a will exceed 10, and thereby FDFB finds no values. So therefore f of a cannot take these values 4, 5 to 10. Of course f of a cannot take 1 also. So you are left with f of can take only 3 values. Those are 0 to 3, 4, 5, 6 up to 10 and 1. These are the things which you are not supposed to consider. So the f of a can take only 3 values. So that is f of a, f of c is 1, f of a is 0, then it will be 3 plus fd, and fd cannot take 1, 0, and fd cannot take 8, 9, 10. If the 8, 9, 10 are taken, it exceeds 10, therefore it finds, fb finds no value. Therefore, other than these 5, fd finds 6 values, 2, 3, 4, 5, 6, 7, the corresponding values of f of b as written here. So you will get 6 1-to-1 functions in this case. So the second case, so 2, f of c is 1, f of a is 2, then you will get 7 plus f of d. F of d cannot take 1 to f of d cannot take 4 to 10 because it exceeds 10, and the remaining values fd can take is 0 to 3. It results in 2 1-to-1 functions. The third case, 1, 3, and if you take 1, 3, this value will become 9 plus fd. Fd cannot take 1, 3, and fd cannot take 2 to 10. Why? Because it exceeds 10, and the remaining values, only one remaining value is here, that is f of d is 0, and you will get one function. The total number of functions will be 6 plus 2 plus 1, that is 9 functions, 9 1-to-1 functions you will get in this case 2. We go to the case 3. In case 3, let f of c is equal to 2. If f of a takes value 3, then 3 times f of c, there is 3 plus 2, 6, 6 plus 2 times of f of a, that is f of a is 3 if you take it, if it exceeds 10, and thereby fd and fb find no values. Therefore f of a cannot take values 3, 4, 5 up to 10, and f of a cannot take 2 values. So the remaining values are, thus f of a can take only 2 values, 0 and 1, other than these 3 to 8, 3 to 4 to 5, 3, 4, 5, 6, 7 up to 10 and 2. So only 2 values are left, and that is tabulated here. So you will get to 2 cases, 2 subcases, 2, 0, 2, 0, and if you take f of c is 2, f of a is 0, this value will be 6 plus f of d. If you take f of d is 5, it exceeds 10, and thereby you cannot find f of b. Therefore it cannot take 5, 6, 7, 8, 9, 10. The remaining values f of d can take is 1, 3, 4. It results in 3 1-to-1 functions. In the case of f of a is 1, then you will get f of c is 2, f of a is 1, 8 plus f of d, and f of d cannot take 2 and 1, f of d cannot take values 3 to 10 because 8 plus f of d will exceed 10, and thereby you cannot find the value for f of b. Therefore f of d can take values only one value, that is, and you will get, it results in only one 1-to-1 function, and the total number of functions in this case is 4. We go to the last case, case 4. Let f of c is equal to 3. If 1 less than or equal to f of a less than or equal to 10, then 3 times f of c plus 2 times f of a will exceed 10. Thereby fd find no values. Therefore f of a cannot take the values 1 to 10. Of course that 3 is also included here. So thus f of a can take only one value, that is the only one value that is left, that is 0, and it results in one function. So this is the 1, 3, 0, 9 plus f of d, and f of d cannot take 3, 0, and if f of d takes 2 value 2, then 9 plus 2, 11, it exceeds 10, and the similar argument will follow. And you will get the possible value for fd is 1, and you will get one function. So summarizing all these cases, we get 17 plus 9 plus 4 plus 1, 31 1 functions. 1 functions. The answer is 31. So let's look the summary here. So that is our tabular form. So that is your case 1, and you get the sum of these things is 17. In the first case, 17 1-to-1 functions you will get. In the second case, you get 6 plus 2 plus 1, 9 1-to-1 functions. In the case 3, you will get 3 plus 1, 4. In the case 4, you will get 1, and the total number is 17 plus 9 plus 4 plus 1 is 31. So the total number of 1-to-1 functions is 31. So our final answer is the number of 1-to-1 functions from the set A, B, C, D to the set consisting of 0, 1 to 10, satisfying 3 times FC plus 2 times f of A plus f of D is equal to f of B is 31. So that is the discussion of the solution of the given problem, and it is to count the number of 1-to-1 functions in a given scenario. It is definitely a tough question to answer in the examination because the enumeration do not follow a formula here. So you have to physically count all those things, taking all the considerations into account. So in the examination, it is certainly a difficult problem to answer. However, such questions will come now and then. Very rarely such questions will come. And I'm sure that you have understood my argument. And I wish you all the best. Thank you.